Hello and welcome to ZAPCon. This is Starting a Security Program on a Shoestring with ZAP. I'm Brian Myers. This talk describes how a software development team might take the first steps towards setting up a security program by incorporating a vulnerability scanner, such as ZAP, into their work. This slide is the Why You Should Listen to Me slide, the point being just that I do have some experience relevant to this topic. This talk might interest you if your goals include any of the items on this slide. This talk isn't just about how to use a scanner like ZAP. It's also about the role a scanner plays in a broader security program. I first gave a version of this talk at a quality assurance conference where I wanted to talk about how individual development team members who want to learn more about security can get started. People ask me that sometimes. They say, what you do looks interesting. I'm glad to hear that. How could I get started? It seems like a broad field. I don't know where to dig in. What could I pick up that would be useful? How many books do I have to read? What certification do I have to get before I can do something practical? So this talk is partly about how someone new to security could begin building expertise, also while making your product more secure, and at the same time contributing to the company's culture of quality. Security is a broad and daunting field, and finding the right starting point is tricky. In order to explain my answer, I structure the talk as a response to an imaginary situation. So suppose you are part of a small development team with a web application, no security expertise, and limited resources, not a lot of money you could spend on making things better. Someone decides the product needs to be secure. That could be you, maybe you're just interested, or maybe it's a customer or an auditor, whatever the reason is. Security becomes a priority. What should you do? How can you make meaningful progress with minimal knowledge? Given that situation, what's the best way to get started, and how far can you go? There are two approaches to a problem like that. One would be to hire experts, get training, identify risks and threats to your company, prioritize the findings for the business to address, and design and implement a full security program. And in some sense, that would be the right way to go. But it makes for a slow start with a lot of heavy lifting up front. And of course, it won't fit the hypothetical situation I just imagined, a small company with no resources. So what we'll do instead is think of a way that you could get some progress working on your own. I propose that there is, in fact, an easy way to get quick results and long-term improvements with minimal initial investment, just by incorporating a vulnerability scanner into your software development process. Learn by investigating what it reports. So many of you at ZAPCon probably know all this, but part of the point of this is to explain the process to new people, to give us all an idea of what it's like when they approach this stuff for the first time. And when you say they need a scanner, it turns out a really important question to walk them through is, what is it exactly they want to scan? Because there are more kinds of scanners than one. There are 4 different types at least, probably some others I don't know about. So there are network scanners that scan your infrastructure and tell you if your servers are patched, if your ports are hardened. There are static application testing scanners, SAS scanners that read your source code, that look for problems in the programming logic. Perhaps there's something you've done that might be exploitable as a memory buffer overflow error. There are composition scanners, composition analysis, that look through the build artifacts, not the source code, not the infrastructure, but the build artifacts to see what third-party libraries it can recognize in your product, like are you using .NET or jQuery. And then it'll go look up in the real world a list of well-known current bugs in old versions of that software and tell you if you have known security vulnerabilities in your application from third parties. And finally, there are dynamic application security testing scanners, DAST scanners like ZAP, that will interact with a running application and report flaws in the web pages. And all 4 types of scanners are useful. And in a good security program, most companies use all 4 and collect different data from each one. But for the project I'm imagining here, there isn't an existing security program. There's no one who's expert in doing any of these things. I'd suggest the right place to start is with a DAST scanner. The next question then is which one? For this talk, I did some research into free scanners, and here's a list of tools that I found mentioned favorably in articles or reviews. Notice that some of these scanners are no longer maintained. It also turns out that a few of them do only one thing, like WFuzz and SQL Map are focused on very specific kinds of testing, finding certain kinds of vulnerabilities. So let's think about our criteria for selection. For the particular problem I imagined, that small group, it mattered to me that the product should be free. It should be actively maintained so that it doesn't fall out of date. If you have something that hasn't been touched for 3 years, then that's 3 years worth of developing security knowledge that has not been incorporated in your scanner's ability to search for vulnerabilities. So you definitely want something that's getting improvements all the time. You also want something that detects a range of vulnerabilities. It isn't just specialized for one thing like SQL injection. You definitely want something that produces useful reports that you as a beginner can understand. And you need something that integrates with the build process. You don't actually need that right away, but it'll become important later, so it's useful to put that in as a criteria up front. In practice, the first two criteria, is free and is actively managed, narrowed the field quite a bit. Down to these four is what I ended up with. Arachne is great, and in some ways for this situation might have been my favorite, except that it's no longer supported. It hasn't been added to since 2017, and it took till 2020 for the owner to admit that actually it's not getting anything. So that's out. W3AF is much praised, but hasn't seen a lot of code changes in the last 10 months. Wapiti is an honorable contender, and you could choose that, but it looked to me like OWASP addresses a broader range of vulnerabilities, the ZAP product does. And it certainly has a vigorous community contributing to it. It's improving a lot and has check-ins very often. It's also backed by OWASP, a well-known international open source organization whose purpose is to help companies produce secure code. And it is one of their flagship products, which makes it very likely to continue and continue receiving the kind of attention that will keep it being a good tool. So that was my clear winner. By the way, I did this study and came up with that conclusion 2 years ago before I'd heard of ZAPCon. So I've walked you through what a scanner is and how to pick a good one. I've suggested one you might pick. The next thing is to point it at your site and get it running. And with most scanners, you just give it the URL, and you can see here under URL to attack that I'm pointing ZAP at a site called Mutilidae. This is a well-known website. You can download it yourself on the net, built some years ago for pedagogical purposes, and it is a website with many vulnerabilities in it. It's got lots of security problems. So there should be plenty for ZAP to be able to find in there. People who are new to vulnerabilities may find this next step the hardest, and so I'm going to spend some time on it. And that's the step where you get findings and you need to act on them. And the hard part at first is interpreting what the scanner tells you well enough to understand what the problem is and to be able to reproduce it yourself in your own website without the scanner so that you can tell when it's fixed. Also, you need to do that yourself sometimes in order to see how serious the problem is or to confirm that it really is a problem. So the goal of the next few slides is going to be to walk you through reading scanner input well enough to reproduce the problem. This slide shows typical pieces of information that any DAS scanner reports. It may give it slightly different names. These are the names that ZAP uses, and it reports other things as well, but these are the things that are going to matter in the next couple of examples. In the left column are facts like the kind of vulnerability, a description of it, the risk level. All the things in that column are general facts about a kind of vulnerability, and they're not specific to your site. The references, for example, at the end are URLs to places on the internet, articles, blog entries, OWASP, Microsoft maybe, where you can go to find out more about this kind of vulnerability. The things I've listed on the right tell you exactly what ZAP did in your site that made it think something might be wrong. So really that's the key over there. Here is an example. The findings that were, these are the fields that were relevant when ZAP found what it believed to be a path traversal problem in the Mutilidae site. So I get an alert name, path traversal, that's the kind of vulnerability it is. I'm told that ZAP thinks this might be a high severity problem. I get a description, and if I'm not already familiar with path traversal, I can probably at least figure it out. It has something to do with access to files and directories in a way that is apparently bad. And there's a URL. You can see the URL points to the Mutilidae site. Then we get into some really specific details. The attack that ZAP ran, from which it concluded there was a problem, involves a parameter named page. And in this case, if you look at the URL, you can see that, in fact, the query string has on it a parameter named page. And that is almost certainly the parameter used in this attack. You also get an attack string. That's the string that begins /etc password. So that attack string was fed to that parameter and produced a problem. How did ZAP know there was a problem? How did it recognize it? Because it searched the HTTP response for this evidence string, root:x:00, and it found that evidence string, and it concluded there's a problem. Now, if you don't know what path traversal is, and if you're not familiar with Linux systems, it may not be clear to you at first why this is a problem. And so that's why you want to be able to reproduce this behavior in yourself to see what a user would see if you in this event. So let me walk through exactly what's going on in the HTTP level to show you, it's probably clear, but just to be explicit, how ZAP found those details it reported. When the scanner runs, it does there are at least two phases to its attack. There's a passive phase where it crawls the website and doesn't submit any forms, doesn't try to attack anything really, it just reads. It follows all the links to find all the pages in the site, and it catalogs what it finds. And in that stage, it saw this link go by. This is how you reach the login page in Utilidae. And it said to itself, there's a page parameter there. Maybe I'll do something with that later. When it gets to the active attack phase, it remembers that parameter and it goes back and says, well, I'll do what a hacker would do here. I will paste in, instead of login.php, the expected value. I'll put in an unexpected string to see if anything bad happens. And the string it chooses is, of course, the path to a well-known system file in Linux that should not be accessible through any web server. So that's the attack string. And these little bits in red are what ZAP took out and gave you back as the parameter and the attack string in the finding report. Then the last step is, once it's sent the attack, it's requested the URL with the attack string on it. It looks at the response and it scans to find the string that would indicate an attack. In this case, it found it, root:x:00. And so it added this to this page and this URL to its list of findings. Okay, so what does that mean in the website? How do you reproduce it? Well, that's simple, of course. You pull up the Utilidae website, you go to the top and you type in that URL, the one that ZAP tried in the table up there, the one with the attack string in it. That's the URL encoded /etc/password as the value of the page parameter. And you press return, and this is what comes back. You can see it on the screen. You can see the Utilidae website, Chrome at the top with its navigation bar, menu down the left. And then in the lower right hand, where I've got a red circle around root, that's the content, and that long string there is not what the developer expected ever to show up on that page. That is, in fact, as you probably see, the contents of the password file on the Linux server where Utilidae is residing. So that's absolutely bad. This means a hacker could go to that site, type in well-known file names and paths, and fish up unexpected content, unauthorized content from the website. So in this case, ZAP has absolutely found a problem. And when you get this far, it's easy to see what the problem is. And to get there, you just had to be able to read the information that ZAP gives you in the scanner. Let me walk you through one more. This time, ZAP tells me that it's found something it thinks is SQL injection in the Utilidae site. ZAP believes this too is a high priority problem. And there's the URL. It is in fact almost the same URL that happened to be in the last finding. But you'll notice that this time the page parameter is allowed to have its expected value of login.php. The problem is somewhere else this time. The problem now is with a parameter called username. We're on a login page. It's not surprising there's a username parameter somewhere. And this time the attack string is something that looks like Brian and 1 = 1. Brian, besides being my name, is actually the name of a registered user in my copy of Utilidae. Then there's some other info that I didn't show you before because it didn't have important information on the path traversal finding, but for the SQL injection, it turns out to be really helpful. It says the page results were successfully manipulated using the Boolean conditions Brian = 1 and 1 and Brian = 1 and 2. So in fact, what this means is there were 2 attack strings. It submitted the page twice, once with each attack string. And if that other info wasn't perfectly clear, because you're working with an open source tool, in this case, ZAP, you can actually go, as I did, and open up the source code for the tool and find out what the attack did, why it needed 2 attack strings, and why it concluded there was a problem. It submits the request once with each attack string, and it compares the result. And it expects the same result from both, but it got different results. And that's how it decided there was a problem, which doesn't really tell you exactly what the problem was, but it is correct. It reached a correct finding. Let's go further and see exactly what happened. So this is a bit of the login page that ZAP was attacking. Sure enough, there's a username and a password. And if you look in the HTTP markup or the HTML markup for this page, you'll see that this is the definition of the username field. And sure enough, the input type text has a name username, and that lowercase string username is the string that ZAP pulled out and gave you as the parameter name that it's going to attack. And the attack string, it basically stuffed into the username field and submitted. So think about this. Suppose you went to a web page and you typed in a value like that as the username and you left password blank and you pressed login. What would you expect to happen? You'd expect that that would fail because with no password, you couldn't authenticate. And sure enough, if you type in Brian and 1 equals 2, utility correctly, it says, aha, that is not a valid set of credentials. You can't log in. And that's what it looks like. So with that attack string, no problem. But if you type in the other attack string, Brian and 1 equals 1, you get a very different result. No error message at all. And if you look at this and try to figure out where you are and what happened, I'll draw your attention to a couple of things there. You've actually logged in. You've logged in as Brian. You typed in an invalid username and no password, and you were authenticated. You got unauthorized access to the site. That's definitely a problem. Go ZAP, definitely high priority, something to fix. And if you don't know how to fix it or aren't sure what SQL injection is, the findings also have links in the references field to online information about SQL injection. And that's exactly where you should start learning if you haven't already picked up that knowledge. So now we've walked through 2 examples of reading a ZAP report well enough to be able to reproduce the bug yourself outside of ZAP, which I say again is one of the hardest things for new people in my experience. The next thing you need to know about DAST scanners is that not everything they tell you is actually the gospel truth. This is a picture of a grain of salt, and you need it in reading any DAST scanner results. Most scanners are not 100% accurate. So there are 2 kinds of problems they have. One is false positives, where they look at evidence and they draw the wrong conclusion about what they're looking at. That's another reason why it's important for you to be able to reproduce what ZAP says it saw in the site yourself, to be able to confirm that it really is a problem, that something significant actually went wrong. Because sometimes when you go through those steps, you'll discover it isn't really a problem at all. The next thing you need to but be aware of when you're using a program like ZAP is to think carefully about the risk ratings. They're usually right, but not always. Scanners don't know your site. They don't know what you have to protect or where in the site it lives. They don't know what any particular vulnerability would really let an attacker do in your site. So when they put a risk rating there, it's a general rating. It's based on general knowledge of how easy it is to exploit usually this kind of vulnerability on a website and what sorts of consequences generally follow. But you can imagine in that path traversal case, for example, you might have a misconfigured web server that allows fishing up files like that, but it might be configured in such a way that the only files you could get to with your path traversal were innocent. Maybe they're not things you intended to serve up, but maybe they're not dangerous. They're not details about the system, but maybe old drafts of marketing documents or something like that. Not something you want to serve, but you would be entitled at that point and fully justified in disagreeing with what the scanner reported and saying, no, that's not high priority for me. I'm going to treat that as a medium or even a low priority vulnerability. So false positives and a certain amount of hysteria in over-assessing the possible severity of bugs that it finds. Those are things to know about scanners. So what we've seen, I can say at this point, if you take a website and you add ZAP to it, the result is a list of vulnerabilities or possible vulnerabilities in your site, prioritized for you by likely severity. And that list is a perfect answer to the question I imagined someone asking at the beginning. How can I get started in security? It's this huge field. Where do I start? ZAP just handed you a list of things you need to know in order to be sure your site is secure. There are a lot of items. The important ones are at the top. Pick up the first one, and if it's not already something you're familiar with, read about it, understand the report well enough to reproduce the problem, find out what the standard fixes are for defending against that attacks through that vulnerability, talk to your development team about it, get a fix in. Great, you've made progress. Your app is more secure. You've learned a few things. Your expertise increases item by item as you go down that list. So supposing you've made your way to the bottom of the list, and supposing you've actually managed to address every single bug on it, what does that get you? Does that mean you have no more vulnerabilities? Are you invulnerable now? No, alas, it does not mean that. It just means that you have fixed some well-known vulnerabilities. Scanners are programmed to find certain things, and they won't find vulnerabilities they're not programmed to know about. And some vulnerabilities are not easily captured by a scanner. They may be too complex to be scripted easily. They may reproduce in a non-deterministic way based on a race condition that a hacker would exploit, but a scanner might not be able to reliably discover. The vulnerabilities might be too newly discovered to have been included in any scanner script yet. And of course, we've only run one kind of scanner. I mentioned at the beginning that this is a DAS scanner, but there are SAS scanners and composition scanners and infrastructure scanners, and all of those find different vulnerabilities than this did. If you ran all of those, you'd be in better shape. Still, I don't want to underplay what you've accomplished by following the steps this far. You have made your application harder to attack, and you have at least avoided a set of common, well-known problems, and that is absolutely worthwhile. Having done that much, let's review. What are the benefits that have accrued to you at this point? Your application vulnerabilities got fixed. Good. You learned about security. That's good. Your team learned some things too, because I'm assuming that you have a small team and that you didn't do all the testing, all the confirming, all the triage, all the fixing, all yourself, that someone else was involved. So your team is learning about vulnerabilities. The team becomes more aware of security as they work, which means the team is very likely to think about security sooner. If you just fixed a SQL injection problem on one web page and you start to make another, you'll be more aware as you build it of how it might be exploited, and you'll probably remember to take whatever defense you put in the first page and apply that to the second one. And in fact, at that point, you might start building standard reusable defenses for SQL injection or for anything else. You might common standard defenses that teams build in a reusable way for themselves include validating user input, which addresses SQL injection, encrypting data that has reusable functions, logging functions so that you can produce a log that's good for auditing in the event of forensic activity after an incident. You want to control what error messages display to users if something goes wrong on production. Those and other areas are susceptible to reusable code, and so your team may discover there are practices they can build, reusable bits, that will help them be secure in other places. So those are some of the benefits you've accrued. And having got that far, there's one more tiny step you could take that would move your effort to the next level. And that is to commit to using the scanner regularly and to write down what that commitment is. So if you're on an agile team, you'd think of it as a team working agreement. Who's going to run the scanner and how often? Who's going to process the results of the scanner and turn them into bug reports? How quickly does that triage need to occur? Is it okay if the scanner results sit there for a month or a week or a day? What's right for our organization? And how quickly will the bugs be addressed? I put a space there because the kind of extra credit at the end would be, you might also consider, if you're running the scanner every month, say, that every 6 months you might look over the history, the last 6 reports, for trends. Are you discovering more bugs or fewer bugs? Are there certain kinds of vulnerabilities that no longer occur that there were a lot of at the beginning that you can therefore demonstrate you've mastered? Are there certain kinds that are becoming more common that maybe you need to learn more about? If you have written that down, then what that does is it's a difference between being secure because you have a few motivated people working on a team who want to do the right thing and being secure as a systematic organizational behavior. If you write this down and you introduce new people, as new people join the team, introduce people to the working agreement, that means you are systematically cultivating in new people and asking of them the same behavior that you found produces good code in your system. And if you do that, you're really only a step or two away from a number of other potentially beneficial practices. That document we just wrote, that working agreement, you can call your vulnerability management procedure. In fact, once you've gotten as far as creating that document, you actually have a vulnerability management program, which is something auditors and customers would love to hear. If you started, as I suggested, developing reusable defenses for common kinds of vulnerabilities, then you should make another page in your wiki and call it your secure coding guidelines. And you should add to that every such practice that you develop. This is how we scan user input and validate user input. This is how we encrypt. Whatever it is, just add it to the page. And now you have secure coding guidelines. Then, when new people join your team, you can ask them to read the secure coding guidelines. And if you do that, you can tell people you're training new users as they come in. Yeah, you could do better in training. It would be easy, in fact. Besides having them read the secure coding guidelines, you could point them to a free video on YouTube that gives you a 20-minute introduction to common web vulnerabilities. I even have one of those listed in the resources at the end of this deck. So then you're training people. You've got coding guidelines. Maybe you've got a video on web vulnerabilities. You're ensuring that people who join your team always arrive with at least as much knowledge about vulnerabilities as you have. You could even record if you have like an onboarding checklist for all the things that people have to do when they join your company. Get them a laptop, get them an account on the user domain, on the domain. You might also say, be sure they've read the secure coding guidelines and ask them a question or two to see if they understand. Check that off. Now you have attendance records to prove that you are training employees as they come. If you do what I suggested and every 6 months look at your trends to see if you're improving over time and maybe take some notes about what you concluded when you looked, then you have metrics over time and you're managing the change and observing whether you're getting better or worse. All of these things are artifacts of compliance, which are what auditors look for when you need to prove to someone that you're doing the right things, which not all businesses need to do. This won't apply to everyone. But if you are in that situation, you have the working agreement, that document that you created, that's an artifact. You have a report from each time you ran the scanner that proves that you're running the scanner. You have defect reports in your bug tracking system that shows that you didn't just run the scanner, you actually reported those as bugs and got them fixed. You have training materials, attendance records, secure coding guidelines, metrics collected over time. That's really quite a bit, many steps towards a secure development lifecycle program. And you've done that with minimal upfront investment. Now, since for a living I work with a complete security program, I feel obliged to point out there are other things you would ideally want, but you don't have to get them all at once. These columns here are each of them phases, common phases in a normal software development process: finding requirements, designing a solution, building the code, testing it, deploying it, maintaining it. At each stage, there are security-specific things that should happen and should happen systematically. And you haven't got all that just by adapting a DAST scanner, which, by the way, does show up in the test column here. But you have made a lot of progress towards your goal simply by that one step. That's the end of the slides. I did have a few resources to share. The first 3 items here are all of them introductions to common web vulnerabilities, and each presents the information in a different way. OWASP gives you very factual-oriented cheat sheets with lots of details and examples. The Hacksplaining site has pleasant, faintly entertaining animated demonstrations of each vulnerability type. The Dev Central site has a YouTube video where someone talks to you about them. The next 2 items there are lists of vulnerability scanners and comparisons of them in case you get interested in looking at other tools as well. And the last one is a version of this talk written out as a document, as a paper. I don't know if that's interesting to you, but it does have a little more detail than I was able to give in this talk. And so if you want more information, that's a place you could go. I'd be happy to hear from you if you have questions. This is how you can reach me. I am Brian at safetylight.dev. Thank you very much.